Beneath the quiet surface of Yellowstone Lake, a signal started. A slow, persistent pulse that scientists had never recorded before. Not a violent tremor, not a sudden rupture. It was something new. An earthquake swarm that refused to stop, whispering for more than a year from the heart of a sleeping supervolcano. And when you live on top of a beast that's capable of ending civilization, you listen to every whisper. Before we go any further, I have a question. When you think of Yellowstone, what's the first image in your mind? The beauty of the geysers, or the power of the volcano? Let me know in the comments. It actually helps us figure out what parts of these stories matter most to you. Most people watching this will get so drawn into the story that they'll forget to subscribe. We have a huge viewership, but a tiny subscription rate. If this is the kind of deep investigation you came for, click that button now. It's the only way the algorithm knows you want to see the next one. Let's begin. The event didn't begin with a bang. It began in July 2022, deep beneath the northern waters of Yellowstone Lake, in a place called Noranda Creek. A tiny tremor, then another, and another. This was normal. Yellowstone National Park is one of the most seismically active places on the planet. It trembles constantly, with 1,000 to 3,000 earthquakes recorded every single year. More than half of those occur in swarms. A flurry of activity that can last for days, or weeks, and then disappears. It is the park's normal rhythm, the breathing of a restless giant. But this was different. Past swarms, like the massive 2017 Maple Creek event that produced over 2,400 quakes, hit hard and fast. They started with a frenzy and then faded. They followed a predictable script. This one did not. There was no main shock, no initial burst of energy, just a slow, steady, stubborn drumbeat of seismic noise. Week after week, month after month, it just kept going. By the time the swarm finally quieted down in 2023, the University of Utah seismograph stations had located over 800 individual earthquakes. None of them were large. The biggest, a magnitude 2.9, was too small to be felt by any of the millions of tourists walking the boardwalks above. This was not a story about violent shaking. It was a story about unusual behavior. As Michael Poland, the scientist in charge of the Yellowstone Volcano Observatory, put it, the swarm was unusual because of its persistence. It wasn't the biggest, it wasn't the strongest. But the fact that it just kept going was something they hadn't seen before in this part of Yellowstone. A new signal, a new dialect from a system that is 631,000 years old. The question was simple. What was it trying to say? To understand the signal, you have to understand the place it's coming from. Yellowstone is not a park. It is a caldera, a 45 by 30 mile crater left behind by a volcanic eruption so vast, it defies modern comparison. The last time it truly erupted, 631,000 years ago, it ejected 240 cubic miles of rock, dust, and ash, creating a formation known as the Lava Creek Tuff. Enough material to bury the entire state of Texas 5 feet deep. That is the power sleeping beneath the geysers and the bison. So when it starts acting strangely, scientists take notice. They don't panic. They listen closer. The swarm near Noranda Creek was centered at a depth of about 4 to 5 kilometers, deep, but not impossibly so, and its location was critical. It was happening directly on top of what geologists call a ring fracture, a massive circular fault system that marks the boundary of that ancient caldera. These fractures are the volcano's old wounds. They are natural weaknesses in the Earth's crust, natural superhighways for whatever is trying to move around deep underground. That's why this persistent whisper was so unsettling. It wasn't just a random series of quakes. It was a sustained event happening on a primary structural feature of the supervolcano itself. The Yellowstone Volcano Observatory, or YVO, is not one group. It is a consortium, a team of rivals united by a single mission: to watch this volcano. It's led by the US Geological Survey, but it brings together the seismic expertise of the University of Utah, the geological knowledge of the University of Wyoming, and the on-the-ground presence of the National Park Service. It is the most advanced volcano monitoring system on Earth. Their job is to distinguish between the normal noise of a living volcano and the genuine signal of an impending eruption. To do that, they have an arsenal of instruments, hundreds of seismometers buried across the park, listening for every tremor. A network of high-precision GPS stations that can detect changes in the ground level as small as a few millimeters. Satellite radar that maps the entire caldera from space, watching it breathe. Because Yellowstone does breathe. The entire floor of the caldera rises and falls in long, slow cycles. From 2015 until late 2023, the ground was steadily sinking, a process called subsidence, at a rate of about 3 centimeters or 1.2 inches per year. It was deflating. Then, in late 2023, that trend paused. By early 2024, it had begun to switch to a slight uplift, rising at about 2 centimeters per year. This is not a sign of eruption. The scientists are clear on this. This is the volcano's normal respiration, driven by the complex dance of hot water, gas, and deeper magma far below. An inhale and an exhale, played out over years. But the Noranda Creek swarm arrived during this period of change. During the final months of a long subsidence cycle, just before the system began to reinflate, a coincidence or a symptom? To find out, the scientists at the YVO and the University of Utah, led by researchers like Jamie Farrell, did what they do best. They dissected the data. They looked at the seismic waveforms, the digital fingerprints of each tiny earthquake. An earthquake caused by rock breaking under pressure, the kind that might be caused by moving magma, looks different from an earthquake caused by fluids moving through existing cracks. It has a different signature, a different sound. And the sound coming from beneath Yellowstone Lake was not the sharp crack of breaking rock. It was the low-frequency rumble of fluid. The conclusion was clear. This swarm was not caused by magma. There was zero evidence of molten rock forcing its way toward the surface. Instead, all signs pointed to something far more common in Yellowstone, but manifesting in a new way. Water, superheated water, and dissolved gases, like carbon dioxide, moving through that pre-existing ring fracture system. This is a process known as a change in pore pressure. Imagine a sponge full of cracks. If you force water into it, you can cause the sponge material to shift and vibrate. That's what was happening 5 kilometers beneath the lake. A massive hydrothermal system flexing its muscles. This was the answer. A verifiable, data-driven, scientific explanation. And it was still unsettling. Because explaining what happened doesn't explain why it happened this way, this time. The hydrothermal system has been there for thousands of years. The ring fractures are ancient, yet they combined in 2022 to produce a swarm with a slow, persistent character that the scientists, the very people who have studied this volcano their entire lives, had never documented before. They had an explanation. They did not have a precedent. If you're still here, you're clearly one of the few who values depth over cheap entertainment. So I'm going to be direct. We have a shockingly low number of subscribers compared to how many millions of people watch these videos to the end. It takes 1 second to hit the subscribe button. It costs you nothing. But it tells the algorithm that this work matters, and that allows us to make more of it. Think of it as an emergency broadcast system for curiosity. Please, click it now. The Noranda Creek swarm was not happening in isolation. Across the park, another one of Yellowstone's famous features was also displaying unprecedented behavior. In the Norris Geyser Basin, one of the hottest and most volatile thermal areas in the world, sits Steamboat Geyser. It is the world's tallest active geyser. A major eruption can blast water more than 300 feet into the air, a display of raw thermal power that dwarfs Old Faithful. But for most of its recorded history, Steamboat was sleepy. Its major eruptions were famously rare and unpredictable, sometimes separated by years, even decades of dormancy. From 1991 to 2018, it erupted just once. Then, on March 15, 2018, it woke up, and it has been throwing a record-breaking tantrum ever since. Since that date, Steamboat has erupted more than 225 times. In 2018, it erupted 32 times. In 2019, a record 48 times. In 2020, another 48 times. A frequency that the USGS literally calls unprecedented in its recorded history. It went from being a geological curiosity to one of the most active and reliable major geysers in the park, almost overnight. Like the Noranda swarm, the hyperactivity of Steamboat is not a sign of impending volcanic eruption. It is a hydrothermal phenomenon, a change in the plumbing system that brings boiling water to the surface. But it's another data point, another piece of the volcano's complex machinery behaving in a new and extreme way, at the same time that other parts of the system are also sending strange signals. Are the two events, the persistent swarm and the hyperactive geyser, directly connected? Michael Poland and his team say probably not. the plumbing systems are likely separate, but they are both being fed by the same engine, an enormous reservoir of heat from the magma chamber deep below. They are two different symptoms of the same underlying condition, that Yellowstone is a living, breathing, and fundamentally unstable place. If this story is something you'd end up talking about with family or friends over dinner, do them a favor. Hit the like button and share this video with them. It helps get these important conversations started beyond just our screens. Thank you. The constant low-level humming of Yellowstone can create a kind of complacency. Thousands of tiny quakes a year become background noise. The ground breathing by a few centimeters becomes a routine data point. But the region has a memory of what real power feels like. That memory is etched in the night of August 17, 1959. Just west of the park boundary, beneath Yellowstone Lake, a fault ruptured. Not a volcanic event, but a purely tectonic one. The entire Intermountain West is being slowly stretched apart, and that stress builds up in faults. On that night, the stress was released. A magnitude 7.3 earthquake struck the region. In Yellowstone, the ground shook so violently that it changed the behavior of the geysers. Some, like Grand Geyser, went dormant. Others, like Sapphire Pool, began erupting violently, destroying its own delicate sinter formation. The earthquake triggered a massive landslide that dammed the Madison River, creating a new lake, now known as Quake Lake, and tragically killing 28 people who were camped nearby. The 1959 quake was a brutal reminder that Yellowstone sits at the intersection of multiple immense geological forces. There is the tectonic stress of a stretching continent, which causes earthquakes like Yellowstone Lake. There is the hydrothermal system, a labyrinth of superheated water and steam that powers the geysers and causes over 99% of the park's earthquake swarms, including the one at Noranda Creek. And then there is the magmatic system itself, the deep engine of heat that powers everything else. The unprecedented swarm of 2022 was purely hydrothermal. It was not a sign of magma on the move, but it took place in a landscape that has been violently reshaped by tectonic power, and which was created by volcanic power beyond our comprehension. Nothing in Yellowstone happens in a vacuum. Every new signal has to be read against the backdrop of this violent, complex history. The ghost of 1959 is a permanent reminder that the ground here is not stable. It is not finished. For decades, the work of geophysicists like the legendary Robert B. Bob Smith of the University of Utah was about establishing the baseline. He and his colleagues built the very seismic and GPS networks that now serve as the park's nervous system. They mapped the magma chamber, traced the fault lines, and gave us the language to understand the volcano's normal state. They defined what quiet looks like. The problem in 2022 was that the volcano was being quiet in a whole new way, a slow, persistent tremor that didn't fit the established patterns of normal. It forced a new question. Not, is this the big one, but is the definition of normal changing? This leads directly to the internet's favorite myth about Yellowstone, the idea that it is overdue for a super eruption. The logic is simple and deeply flawed. The last three major caldera-forming eruptions happened about 2.1 million, 1.3 million, and 631,000 years ago. The math seems to suggest a recurrence interval of about 600,000 to 800,000 years. Since we are over 631,000 years past the last one, the clock must be ticking. But volcanoes do not work on a schedule. The internet plans for deadlines. Geology operates on statistical probability. The USGS is very clear about this. The annual probability of another super eruption at Yellowstone is roughly 1 in 730,000. That's a 0.00014% chance in any given year. As a point of comparison, your odds of being struck by a civilization-ending asteroid are higher. A volcano is not a bus that is running late. It is a complex system that may or may not ever produce another event of that scale. To say it is overdue is to misunderstand the fundamental nature of the science. The YVO has a clear checklist for what they would expect to see if a massive eruption were genuinely imminent. It would not be subtle. It would not be a whisper. First, there would be intense earthquake swarms, far larger than Noranda Creek, and they would get progressively shallower, indicating something was moving up from below. Second, there would be dramatic ground deformation, not centimeters of uplift over a year, but meters of uplift over weeks or months. The ground would swell like a blister. Third, there would be massive changes in the thermal system and gas emissions. Geysers would change behavior erratically. The ground would heat up over vast new areas, and the gases escaping, sulfur dioxide in particular, would increase by orders of magnitude. None of this is happening. The data from the most intensely monitored volcano on the planet shows a system that is active and dynamic, but not one that is building toward a catastrophe. And yet, the system is now speaking in a new dialect. The Noranda Creek swarm was a sentence scientists hadn't heard before. The hyperactivity of Steamboat is another. These events force the models to be updated. They add new variables to an already complex equation. They don't signal apocalypse, they signal humility. A reminder that our understanding, as advanced as it is still just a snapshot of a process that unfolds over geological time. By mid-2023, the odd little swarm at Noranda Creek had faded away. By June of 2024, the seismic reports from the YVO were back to business as usual. In May 2024, the University of Utah located just 78 earthquakes in the entire Yellowstone region. The largest was a tiny magnitude 2.2. The report noted explicitly, there were no earthquake swarms recorded. The strange signal was gone. The volcano had returned to its normal, restless hum. But the questions raised by the event did not disappear with the tremors. Why did it last so long? What specific change in the deep hydrothermal plumbing caused that sustained release of energy? Is this persistent swarm behavior a new feature we can expect to see again? Scientists are now trying to listen even more closely. In a recent experiment, researchers placed a hydrophone, an underwater microphone, on the floor of Yellowstone Lake. For the first time, they were able to hear the sounds of the earthquakes directly. They described them as thumps. This new sensory input gives them another way to analyze the source of the quakes, to understand the physics of what's happening in the rock. It's a testament to the fact that even after decades of intense study, there are still new ways to listen, new things to learn. We are still leaning in, trying to decipher the language of the deep earth. I know, this is the third time I'm bringing this up, and I promise it's the last. But if you've journeyed this deep into the story, you are one of us. You're precisely the kind of person this channel is made for. Humor me, and just check to see if you're subscribed. One click makes a world of difference and ensures you never miss where our investigations go next. We really would hate for that to happen. What the 2022 event ultimately represents is not a crisis, but a new layer of mystery. It was a geological puzzle. The clues were the waveforms from 800 tiny quakes. The suspects were magma, tectonics, or water. The detectives were the scientists at the YVO. They solved the case. It was the water. But in doing so, they uncovered a deeper truth. The volcano's plumbing system is even more complex and capable of more varied behavior than they knew. They've added a new chapter to the book of Yellowstone's personality, one that describes its capacity for long, slow, simmering expressions of energy, not just violent outbursts. This matters because every new behavior is a data point for the future. The next time a swarm starts, they will have the memory of Noranda Creek to compare it against. Was the 2022 event a one-off anomaly or the first example of a new normal? No one knows. And that uncertainty is the permanent condition of living with a supervolcano. The real story of Yellowstone is not the single thread of a civilization-ending eruption. It is the constant, layered, and interconnected web of geological hazards. It's the risk of a major tectonic earthquake like Debunking Lake. It's the risk of localized hydrothermal explosions, which can blast out craters hundreds of feet wide with little to no warning. It is the quiet restlessness, the constant hum of a system that is alive and powerful in ways we are only just beginning to fully appreciate. The Noranda Creek swarm was not the monster at the door. It was a shadow moving in the corner of our eye, a subtle shift that forced us to look closer, to listen harder. It was a reminder that even when the giant is sleeping, it is not entirely still. The instruments are still listening. The GPS stations are still measuring every millimeter of breath, and the scientists are still watching, waiting for the next whisper from below. The data came in. The analysis was done.